Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on electricity from October-November 2022, Paper 1, Variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding and also you can have better understanding of these questions and also electricity concepts. Let's study together. Let's improve together. For our question number 31, it is given to us a length of wire RS has a circular cross-section. At end R of the wire, the cross-sectional area is A. As you can see, at end R, cross-sectional area is capital A. At end S of the wire, the cross-sectional area is A by 2. So this is A by 2 at end S. Charge Q takes time T to pass through the end R of the wire. There is constant electric current in the wire. So this is very important one. Constant electric current. Simply you can also understand as they are connected in series, it means current is the same. So this is just one wire. So current will be the same. How much charge will pass through end S in a time interval of T by 4? Means if we look at this end for time T by 4, how much charge will pass through this end? Means through this end. For this end it is given to us. If you look at this end for time T, how much charge is passing through this one? Q in time T. Means if you just look at that end for time T, the charge passing through this end will be equal to Q. And if you look at this one for time T by 4, how much charge will pass through this end? We can say that charge, let's say, is Qs. And we need to calculate Qs in this case. So electric current is the same. So we can say I is equal to Q over T QT, and this ratio between Q and T, this one is constant. So this one is constant because it is given to you current is constant. So simply we can say in this case Q over T, this one has to be equal to Qs divided by T by 4, and we need to calculate Qs. So simply we can make Q the subject and we can rearrange. So here we will get Q times, we will have, this is T by 4 and this is divided by T. So if we rearrange, we can write on this one. This one will be QT divided by 4T. So T in this case we can cancel. This T we can cancel with this one. So simply we left with Q by 4. This question is pretty straightforward. Even I no need to do this all steps. I can look at this question, I can find out. Because if this time decreases by 4, this Q means the charge also has to decrease by 4. Because the ratio between these two quantities is constant. So the answer for this question is Q by 4. But I have explained you using all these steps. Because you need to understand concepts and you need to improve your conceptual understanding. Because this concept is not only useful here, you can use this one to approach different type of problems based on the same concept. So that's the reason I hope you have better understanding of this. Let's move on to next one. For our question number 32, it is given to us a power supply is connected to a component by connecting wires of total resistance 4.9 ohms. The power supply has an output power of 36 watts and terminal potential difference of power supply is 12 volts. We need to calculate how much thermal energy is dissipated in the connecting wires in a time of 1.0 hours. So we need to calculate energy dissipated in connecting wires. So how we can calculate energy dissipated? Energy dissipated in the connecting wires, simply we can calculate energy I square R times T. So this is how you can calculate energy dissipated in connecting wires. But here we have value of R, means the resistance of the wires is given to us and the time is given to us. So if we can find out value of I, we can figure out value of E. So in order to find I, we need to look at power output of power supply and terminal potential difference. So I is equal to P over V. We are simply using this formula P is equal to V times I. Now we simply need to plug in these values. So power in this case we have, this is 3.6 watts divided by 12. So we will get in this case 36 divided by 10, and this is divided by 12. So if we solve this one, we will get 3 here. So our final answer will be 0.3 amps, and this current we can use now, and we can calculate value of thermal energy. Current in this case is 0.3 and R is 4.9, and time is 1 hour, and 1 hour has 60 minutes and 1 minute has 60 seconds. So if we multiply this one, we will get our answer about 1588, around this value, around this one. So this is value of E, and the closest answer is this one, C, 1.6 kilojoules. So the answer for this question is 1.6 kilojoules. Up to 2SF we can write down. This one is 1600 joules, or we can say this is 1.6 kilojoules. So the answer for this question is C. For this question, it is given to us a copper wire is to be replaced by an aluminum alloy wire of same length and resistance. Copper has half the resistivity of aluminum wire. We need to find out the ratio between diameter of aluminum wire and diameter of copper wire. So we can make one small table first of all. So we can say for copper, so here we can write down for copper, and we can write down for aluminum. So we have aluminum wire on other side, aluminum. So for this one, it is given to you L, and these two wires, they have the same length, so we can say L. They also have the same resistance, so we can write down the resistance is also the same. And resistivity of copper is half. So if we take resistivity of copper is rho C, resistivity of aluminum has to be 2 rho C, double. And we need to find out the ratio between their diameters. So we can say the diameter of this one, let's say is DC, and diameter of this one we can say this is DAL, aluminum. Now as they have same resistance, so we can write down R, this one is equal to rho L by A, but we can replace A with diameter because we need to find the ratio between diameters. So we can say this is rho L by pi by 4 d squared. So we can write down cross-sectional area, this one will be equal to pi by 4 d squared. Now in this case we have R, that is constant, L is constant, so we can bring L on this side. We can also multiply with this pi by 4, so here we will get this is pi by 4. So we left here with rho divided by d squared. So this side is constant, so we can say the ratio between resistivity and diameter for these two wires is constant. Now we will be using this one. So we have resistivity of copper wire divided by diameter of copper wire. This one has to be equal to the resistivity of aluminum wire divided by diameter of aluminum wire, square of this one. We need to find DAL divided by DC. So we can rearrange, we can say this is DAL square divided by, we just cross multiply, divided by, we have this is DC square. This one has to be equal to rho AL, and we will divide this one here. So this one is rho C. And density of aluminum wire is 2 times of density of copper as it is given here. And we have to divide this one by density of copper. So this density of copper we can cancel. Now we left with this is DAL square divided by DC square. So if, and this one is equal to 2. So if we take square root on both sides, we will get here this is DAL or DC, and this is our final answer. So we have taken square root on both sides, so we got this final answer. So answer for this question has to be A. And this is how you can approach this type of problem. A beautiful way, and you can avoid some kind of trivial mistake if you follow these steps. For question number 34, it is given to us 3 identical filament lamps P, Q and R are connected to a battery of negligible internal resistance as shown in the figure. The filament wire in lamp Q Q breaks so that it no longer conducts. What are the changes in the brightness of lamps P and R? So first of all, let's assume that EMF of this power supply is 9 volts. To just make it simple for you, we can do without numbers, but the purpose of using these numbers is to make it easy for you so you can see what is happening. So if this is 9 volt, and if we look at the resistance of these two resistors as they are connected in parallel, and if we compare that resistance with resistance of this single resistor, let's say the resistance of this resistor is capital R. So I hope you will say resistance of this combination will be R by 2. So we can redraw this circuit. So let me redraw this circuit to make this point clear to you. What is total resistance of these two? Means the R total of this combination. That one has to be equal to R by 2 because they have the same resistance and they're connected in parallel. So resistance will be half. And so if we redraw this circuit, so imagine that we redraw this circuit. So if we redraw this circuit, so in this case, let's say we have one lamp and resistance of this lamp is half. So this one is another lamp. So we have two lamps, means we have two resistors. If resistance of this resistor is R by 2 and resistance of this one is R. If this one is 9 volt and current is the same, so if we connect voltmeter V1, let's say across this one, so this is V1, and we connect another voltmeter, let's say across this one, this voltmeter is V2. So I hope you will say if the reading on this one is 3 volts, reading on this voltmeter has to be 6 volts because current is the same. If resistance is double, it means V is double because V simply is equal to I times R. So this value of V is 6 volt. Now it is given to us filament wire in lamp Q breaks, means this is not conducting electricity. So we can redraw circuit now. If we redraw this circuit, what we have now, we will have simply, this is our power supply. So this one is power supply and we have only two lamps now. So we have lamp P, Q is not conducting, and we have lamp R. So this is lamp R and they are connected in series now. So if we connect voltmeter across, this one is P, this one is lamp R. Now if we connect, let's say this is voltmeter V3 across this one and we connect voltmeter V4 across this, and EMF of power supply is still the same. In this case, I hope you will say they have the same value of potential difference. So the reading on this voltmeter will be 4.5 volts and reading on this one also will be 4.5 volts. So in this case, you can see for lamp P, I can say for lamp P, we can say for lamp P, potential difference for lamp P. So we can say reading will change. The potential difference across lamp P will change from V1 to V3, and for lamp R, we can say for lamp R, reading will change from V2 to V4. So you can see here in this case, we have first of all 3 volts. It increases to 4.5 volts. But in this case, we have 6 volts. It decreases to 4.5 volts. So simply you will say in this case this lamp will be brighter, so this one will get brighter and this one will get dimmer, so this one will get dimmer. Lamp P get brighter and R get dimmer, so the answer for this question is P. So this is a beautiful way you can answer. We can also do this question without numbers, so you can try this one using no numbers, mean without numbers, you will get the same result. I wanted to use numbers because I wanted to make it easier for you to understand. So the answer for this question is A. For question number 35, we need to find out which ratio has the same units as electromotive force. So first of all, we can understand what is electromotive force. Electromotive force is simply equal to energy transferred per unit charge. So we can write down this is energy transferred per unit charge. Energy transferred per unit charge. So this is how we define electromotive force, or simply you can say this is simply equal to E divided by Q. Now if you look at the first one, this is energy transfer, charge per energy transfer, so this is just opposite, so this is not possible. Charge per unit time, this is current, so this is also not possible. Q over T, this is current, so this is also not possible. Energy transfer per unit charge, yes, this one is right, so this is the answer. Energy transfer per unit time, this is power, and this is also not possible answer. So the answer for this question is C. For question number 36, it is given to us a circuit consists of a battery, a voltmeter, and 5 fixed resistors as shown in the figure. The voltmeter reading is 0. What is the resistance of resistor capital R? So first thing we need to understand, voltmeter reading is equal to 0. It simply means that this is balanced Wheatstone page. So this is balanced Wheatstone page circuit, a typical type of circuit. Balanced Wheatstone page. As the reading on voltmeter is equal to 0, so it means this is balanced Wheatstone page. And for balanced Wheatstone page, you need to understand the ratio between these two resistors has to be the same as ratio between these resistors. We can replace these two resistors with one resistor. So you can imagine that this is in one box. So these two resistors, they are in one box. And we can say the resistance of that resistor, let's say, is equal to RT. So Wheatstone page, if it is a balanced Wheatstone page, then the ratio between 2 divided by 5, this one has to be the same as the ratio between this divided by this resistor 10. I hope from here you can simply see that RT from here, if we find out the value of RT, this one has to be equal to 4.0 ohms. So you can simply find out value of RT. So the value of RT is equal to 4.0 ohms. And in this case, we have two resistors. They are connected in parallel. And the total resistance of these two resistors is equal to 4. So simply we can say 1 over 4.0. This one has to be equal to 1 over R plus 1 over 8. And from here we can find out value of R. So we will say in this case we have 1 over 4.0 minus we have 1 over 8, and that is equal to 1 over R. So we can take LCM here. So we can take 8. So here we will get 2 means 8 divided by 4, 2 minus 1, and this is equal to 1 over R. So here we will get this is 1 by 8. So 2 minus 1, we will get 1. 1 by 8, this is equal to 1 over R. So from here simply we can say R is equal to 8.0 ohm. So this is how you can approach this problem, and this question is a repeated question. You can also see this one in other past papers. So this question is repeated question. So this is repeated. You can find this one in other past papers as well. So this is third repeated question in this paper. For question number 37, it is given to us a battery of electromotive force 6.0 volts and negligible internal resistance is connected to voltmeter and 4 other components as shown in the figure. The voltmeter is connected between points X and Y. The positive terminal of the voltmeter is connected to X and negative terminal of the voltmeter is connected to Y. As you can see here, positive is connected to X and negative is connected to Y. It is also given to us initially the resistance of each of 4 components is 1.0 kilo ohms. Which change on its own will cause the voltmeter to show a positive reading. Positive reading means that this potential has to be greater than this one. So first thing we can see, in this case Vx, positive reading. So let me write on here. For positive reading on voltmeter, Vx has to be greater than Vy. So this is first thing you can understand. This reading has to be greater than this one. It means the potential at this point has to be greater than potential at this point. And it is also given to us each component has same resistance. So this one has 1.0 kilo ohms. This also have 1.0 kilo ohms, and this also has 1.0 kilo ohms. Resistance of this one is also 1.0 kilo ohms. If we connect voltmeters now, let's say we connect voltmeter V1 here, the reading on this voltmeter will be equal to 3.0 volts, and reading, if we connect voltmeter V2 here, reading on this voltmeter also will be equal to 3 volts. And if we connect voltmeter here, let's let's say we connect voltmeter V3 here. Reading on this voltmeter will be equal to 3.0 volts as well. And if we connect voltmeter here, let's say we connect V4 here, reading on this voltmeter also will be equal to 3.0 volts. Now we need to understand, we want this reading has to be greater than this one. So we have two ways. One way is that the resistance of this one decrease. When the resistance of this one will decrease, potential drop across this one will go down. So this is one way. The second way is that resistance of this one increase. When resistance of this one will increase, potential drop across this one will increase. When potential drop across this one will increase, potential at this point will decrease. So we have two ways. So we can get positive reading on voltmeter. So I will be writing here. We have two ways. One, if V1 go down, then Vx will go up. So Vx will go up. So this will be more positive than this one. And this can be done if resistance of this resistor go down. So we can say if resistance of this resistor go down, then V1 will go down and Vx will increase. So this is one way. Second possibility we have, if resistance of this one increase, simply we can say if V3 increase, so the resistance of this one has to increase, so Vy will go down, mean it will be lower than 3.0 volts. Vy in this case will go down, so it will be lower than 3.0 because here will be more potential drop across this one. If potential drop across this one is greater, reading on this one will go down. So when V3 go up, let's say V3 increase to 4 volts, reading on this one will decrease to 2 volts. Means the reading here then will be 2 volts, and if they remain same, this is 3 volts, so there will be positive reading. So we have these two possibilities. Now let's look at given options and try to figure out answer. Decrease the temperature of thermistor. Decrease the temperature of thermistor. If we decrease the temperature of thermistor, it means reading of thermistor will increase. If temperature of thermistor go down, resistance of thermistor will go up. So this reading will go up. So it is not possible. This is telling us this reading will go up. So that one is not possible. So this reading will go higher then. So reading on this one will be negative. So that is not possible. So this option is not possible. Increase the resistance of variable resistor. If we increase resistance of this one, potential drop across this one will increase. So if V1 increase, this one will go down. And that is also not possible. So if this go up, this will go down. So reading will be negative. So it means this is also not possible. Now the next one, reduce the intensity of light incident, means this one. If we reduce the intensity, resistance of LDR will go higher. So we can say if light level go down, resistance of LDR will go up, and the potential drop across this one V3, this will go up, and the reading Vy will go down. Mean it will decrease. Let's say this decreases to 2. So reading on voltmeter will be positive. So this is possible answer. So let me explain you this one in a little bit different way. If we want, for example, this reading to increase, so V3, for example, this one will be equal to the resistance of LDR. We can say RLDR divided by resistance of LDR plus resistance of thermistor. And this one has to be multiplied by V0. We can say this one is V0. So if we want this one to increase, we have to increase this one. And if light level go down, this one will go up. So this reading will increase. So if light level go down, resistance of this one will increase. Potential drop across this one will be higher, so the reading at this point will go down, potential will decrease here. As this one is lower than this one, reading on voltmeter will be positive. So this is the answer. Replace the fixed resistor with 5 ohm resistor. If you decrease the resistance of this one, if we decrease resistance of this one, in this case you need to understand this resistance is higher, so the potential at this point will decrease because V2 will go down. If we decrease the resistance of this one, V2 will go down, V1 will go up, and Vx will go down, and that also will give us negative value on voltmeter. So this is also not possible. So the answer for this question is C, and this is how we can answer. I have explained this one in detail. If I want to explain this question very quickly, I will simply go for this one. So resistance of LDR has to increase. When it will increase? When light level will go down, so V3 will increase, so Vy will decrease. So this reading will be lower than this one. Reading on this voltmeter will be positive. So I will answer this way, but I wanted to explain you in detail so you can have better understanding about this problem. I hope this one is clear to you. If you have any questions, please leave your questions in comments. I will explain you as soon as possible. For question number 38, it is given to us an alpha particle passes close to a gold nucleus and is deflected through an angle greater than 90 degrees. Which property of alpha particle changes as a result of deflection? So first of all, let's try to understand a little bit about alpha particle. Alpha particle has 2 protons and it has 2 neutrons. So the charge on alpha particle, so we can say the charge on alpha particle is plus 2e. So when this alpha particle will deflect, you can imagine that here we have gold nucleus. So this is gold nucleus. Let's say this one is alpha particle and this is coming. When it approaches close to this one, it deflects by angle greater than 90 degrees. It goes this way. So in this case, charge will not change. So charge will not change. Nucleon number means 4. This will not change. Proton number, this 2, this will also not change. But momentum will change in this case because momentum is a vector quantity, and in this case, direction of alpha particle is changing. So it means its momentum will change, but rest of the properties will stay same. So simply we can say in this case momentum will change. So this is the answer. For question number 39, it is given to us a nucleus of uranium-238 decays in stages by emitting alpha particles and beta minus particles, eventually forming a lead-206 Pb206. How many alpha particles and how many beta minus particles are emitted during the decay chain? So first of all, let's try to understand alpha decay and beta decay, and then we will answer this problem. First of all, let's try to understand what is alpha decay. Let's say we have nucleus X, its atomic number is A, atomic number is Z, mass number is A, and it decays into another nucleus, let's say Y, by emitting alpha particle. So we have alpha particle. So in this case, the atomic number will decrease by 2 and mass number will decrease by 4. So this is what you need to understand about alpha decay. Let's try to understand beta decay. Again, consider we have nucleus X, atomic number is Z, mass number is Z, and this decay into a nucleus Y by emitting beta minus particle. Beta minus particle in fact is electron. So here has to be electron anti-neutrino. So electron anti-neutrino has to be emitted in this case to conserve lepton number. So this is particle, this has to be anti-neutrino. So in this case you can see the proton number, this will increase by 1, but mass number, there is no change in mass number, and this is the point you need to understand. In this case, there is no change in mass number stays same. So now we can look at uranium. We have in this case uranium 92, it decays into Pb, so it decays into Pb, that is 82, and the mass number of this one is 206. As there is no change in mass number when beta minus particle is emitted, so from here we can find out how many alpha particles need to be emitted. So we have 238 minus 206, so we will get 32. So we can find from here number of alpha particles. So we can find number of alpha particles emitted. They have to be, in this case, 8, because in one alpha decay mass number decreases by 4. So it means there has to be 8 alpha particles. So now we can write down here alpha particles. So we have, this is alpha particle, and here we have, this is beta minus particle. So we can find the numbers. In this case, we have already found it has to be 8 alpha particles. So if 8 alpha particles are emitted, this has to decrease. So if 8 alpha particles are emitted, this has to decrease by 16. So it has to decrease by 16, means the proton number has to decrease by 16. But actually in this case, this is decreasing by 10. So it means there are 6 beta particles. So 16 plus 6, this has to be equal to minus 10. So this decreases by 10. So it means there are 6 beta particles emitted in this case, and there are 8 alpha particles. So we can rewrite here. So we have, in this case, beta minus particle, and beta minus particles has to be 6. Why 6? Because decrease has to be 10. So due to alpha, atomic number decreases by 16, so it has to increase by 6, and that one has to be due to beta minus particles. So our answer is 8 alpha particles and 6 beta minus particles. So the answer for this one has to be 8. And this is how you can approach in step by step in a systematic way. I hope this one is clear to you. So the answer for this question is 8. For question number 40, we need to find out which list of particles contains only fundamental particles. So first of all, let's try to understand what particles are fundamental particles. Fundamental particles simply means that it has no internal structure. So one thing you need to understand, when we say fundamental particle, means that particle has no internal structure, or simply we can say cannot be further subdivided. So this is first thing you need to understand. Cannot be further subdivided. So that particle we call is fundamental particle. Or simply you can say that particle cannot be divided. So we call this fundamental particle. Or you can simply say it has no internal structure. Now if you look at antineutrino, all neutrino and antineutrino, they are fundamental particle. So it means this one is fundamental particle. Beta particle, yes, beta particle also fundamental particle. But mesons, they are not fundamental particles, because mesons consist of quark and antiquark. Let's say up and anti-up quark. So it consists of 2 quarks. So this is not fundamental. So the option A is not right answer. Baryon, they consist of 3 quarks. So they are also not fundamental particles. Neutrino, fundamental particle. Positron, fundamental particle. Electron, fundamental particle. All leptons, they are fundamental particles. Neutrino, fundamental, but alpha is not fundamental particle because it consists of 2 protons and 2 neutrons. So this is not fundamental. Lepton, all lepton family, we have 3 neutrinos and antineutrinos. We also have electron neutrino, means electron, muon, tau, and the neutrino, and antineutrinos. All of them, they are fundamental particles. So leptons are fundamental particles. Quark is also fundamental particle. Positron, this also belongs to lepton family. So this is also fundamental particle because this is antiparticle of electron. So the answer for this question is D. So D is the right answer. And that's all for this paper. I hope you have some better understanding of this paper, and also you have improved your conceptual understanding of these topics.